Hello, and welcome to our program, Astronomy for Everyone. Our program topic for this month will be on the moon, and joining me here in the studio to talk about it is one of our club members, Gary Rapella. Gary, welcome to the program.
Thank you, Don. It's a pleasure to be here, and I hope I can give you an interesting program.
I'm sure you will. I'm sure you will. Well, this lunar observing program, I know there are other programs out there such as the Messier or the Caldwell, but what about this lunar program? Who started it?
Well, Charles Wood, who is a planetary scientist, he's worked for NASA and a number of institutions, is quite familiar with the moon, and he also has a site that gives us the lunar picture of the day that's on the web that everybody can see. But he was a little perturbed the fact that, like you said, there's the Messier list, the Caldwell list, even the Herschel 400 list for deep sky objects, but there was nothing for the moon. So he came up with a list of 100 lunar features that he felt were worth looking at, and gave quite a variety of the features on the moon.
When did he start this program?
He started it in the early 2000s, and actually it made its first light of day in the April 2004 issue of Sky and Telescope, which Charles Wood is a subscribing writer to. And in that issue, he introduced the Lunar 100 for the first time. And in this first issue was just a general description of, well, he listed all 100 objects, what the features were, and what their significance was. And he also gave the latitude and the longitude of the object on the moon, the size. And he also gave a chart, a lunar chart page that was an atlas of the time to where you could find that feature.
Okay, so it sounds like quite a comprehensive program for
Yes.
lunar observing.
Yes.
I know, just being in the club, a lot of people, the members there, seem to concentrate more on the deep sky objects,
Yes.
the galaxies, the other nebula,
Right.
star clusters, and that's fine and very interesting, and other folks are planetary observers, but like I say, the moon seems to sort of get the short shrift when it comes to observing in programs.
Yes, they do. And, there's a lot of information that's out there that can be found. You just have to look for it. Now, what he did after he introduced it, starting the next month, May of 2004, he would take either 2 or 3 of the objects and have a whole article on just them. And this extended for 42 issues.
Oh my goodness.
Yeah.
The editors let him go that long with it, right?
Yes.
Wow.
And so it was good. And when he talked about the feature, he also gave the best times to view this feature. The illustration we just saw for the Apennine Mountains, which is L004, the best time to see this, now this was in February of 2005 issue, is January 2nd, January 6th, 17th, February 4th, and February 18th. Now, that's good for 2004, but what are we going to do for January of 2017?
Good point. Good point.
So what I undertook as my project is to try to find a way to convert those actual dates into a more generic table. And you have some problems. Number one, the moon just won't cooperate. It does not have a nice, tidy 28-day cycle. It's 27.32 days per lunar cycle, which that in itself is enough to throw everything off. And also the moon wobbles a little bit. They call it libration. So at certain times of the month, one edge is tilted more toward us and the opposite edge is away from us and this reverses. So that librations can cause problems because especially with some of the objects that are near the edge, there are some months where they might not even be visible.
Because of this libration or other issues where they...
Right. So, in looking at the Sky and Telescope issues, I would see they gave dates for the full moon, the new moon, first quarter, last quarter. But these dates are all in universal time. So you have to now factor in the difference between universal time and Eastern time.
Okay.
So that's...
And whether we're on daylight savings time or
yes,
not.
yeah, that's factored in there.
Yeah.
So I took all these objects, converted all those dates, and what I came up with is my version of the Lunar 100 list. And I took heavily from Charles' list.
And this is your list right here?
Yes, this is my list, and it shows, you know, the number, the feature, the significance, and then I put in a column instead of latitude and longitude. I put in the month and year of the publication of the Sky and Telescope issue that feature was talked about. So if you wanted to go back and do any further research, you could.
Access it through their digital archive and
Right.
or find your old issue.
Or if you have your own issue, like I still have all of mine, so there's that. Then in the last column was what I came up with. You start out with the new moon. You can go new moon +1, +2, +3, and then first quarter -3, -2, -1, first quarter, and first quarter +1. And so that gives you these dates, and you look up in for your month that you're at, where the new moon is, what time the new moon is, what time the full moon is, what time the first and second quarters are, and then based on that you can check which, you know, what dates for those objects are best seen. Some of them are only good for 1, sometimes 2 nights. Others are good for 3 or 4 days, and some of them are good anywhere up to a week to 10 days. So that came up with my last chart shown here, where I went through actually a 29-day cycle, but it lists my number that I came up with, like first quarter, and what I can see is I can look at L8, L18, 19, 29, 35, 41, 45, 51, 63, and so on. So using this chart, and you've got to make some allowances for the UT portion of it, but I think I'm in pretty close to having the dates well figured out.
So what folks can do then with your list, as you had mentioned, is sort of calibrate it for the particular month and year that they're in, and then they know that whenever that particular feature would fall, say, first quarter, the dates can obviously vary from year to year, and then they can calibrate it up so they would know when the best day is to look at this particular feature, such as the Apennine Mountains.
Apennine Mountains. Of course, you know, if as long as that feature is lit, you can see it, but you might not be able to see it to its best advantage. Especially
during a full moon when the light comes directly at it and bounces directly off. The feature, it's been my experience, and I'm sure yours too, it has doesn't have that pop or that wow, it looks kind of flat.
It does, but also those craters that have rays, the full moon is the best time to look at those features.
Good point indeed. How long did it take you to put this list together?
Off and on, it took me probably about 6 months.
6 months to work through and put it all together? That's a lot of work, and as you said, it was tough, but if it was tough, anybody could have done it, right?
Yeah.
So,
and plus, I learned a lot by doing it.
Where is this list available for people?
Charles Wood does have a site. I can't remember what it is right now, but also if you I could probably get to it through the Lunar Picture of the Day.
Okay.
LPOD, and I think he lists it, and he's also put out a couple of new books that have it.
Okay, or they could just Google Mr. Wood and
right.
find the information that way. Well, this has been an interesting first part of our talk, sort of getting the background and the work you've done to get the list together. In the second part of the show, right after Term of the Month, we'll actually take a look at some of the images that are referenced in the list, and we can talk about the information there for those images. We're going to take a quick break right now. If you'd like to send us an email, please do so. We always like to hear from you. You can see the email address down there at the bottom of your screen. And coming up next is Term of the Month with Stephen Whitty. And after Stephen's done, we'll be back with more Lunar Observing.
Thanks, Don. The Term of the Month for January 2017 is Lunar Terminator. The terminator is the dividing line between the day side and the night side of the moon that you can see, and that's where the long shadows are. And that's the Term of the Month for January 2017.
Thanks, Stephen. Welcome back to the show. With me here in the studio is our guest, Gary Rapella, talking about the Lunar Observing Program. Well, Gary, in the first part, we were kind of crunching numbers and sort of setting up. Now we get to look at the pretty pictures. So let's get started.
Okay, well, before when you look at the pictures, when you go out to observe anything, one thing you remember with the moon, it is bright. And looking at it through a telescope, it gets even brighter. So if you're going to be looking at the moon, I suggest a lunar filter. Mine will not cut out like 85% of the light, cut it down so it doesn't blind me after watching it for a half an hour.
Okay.
And also the program, always do a little research to plan what you want to look at. And one of the things that you can use for that is a lunar atlas. One Charles Wood just put out 3 years ago, and I just got my copy 2 weeks ago. It's the Lunar Atlas of the Moon. It's all photographs from the Lunar Reconnaissance Orbiter that went around and took it. And so this gives you get the picture of the general area of what you're looking at, so you can get to see what's around this feature you're looking for, so that when you look at it, you say, okay, I'm in the right area, then you know where to go to actually see.
Okay, so preparation is the key here.
Key all the time, yes.
Also for the weather, the time of year, obviously, summer or
Right.
winter, and that's the biggest thing that I find when you go out to observe. You want to have a program. You want to know what you're going to look at, because you can waste an awful lot of time trying to
figure that out.
Exactly.
It might not be even above the horizon.
This is true. Very true indeed. All right, well, let's get started with these images, and you can tell our viewers about them.
Okay, the first image is a full moon, and you can see right there on the left, that is the crater of Tycho, L006, one of the biggest one, a fairly large one, and it's fairly recent in lunar geography, maybe 100,000 years plus or minus. And you can see the rays on it that go out from the ejecta from the impact, and they seem to be maybe going more to the up to the north and to the east a little bit. So it kind of shows you maybe which direction the impact was from.
Exactly.
So if you go up and over up to the north and a little bit to the left is the crater Copernicus, and this is L005. It's another impact crater, and it's much older than Tycho, and it has darker rays because it's in the marrow where it's basic lunar basalt, which is darker. So that's why you can have dark rays and light rays.
Okay.
The light rays are more very, very close to the surface. And
Of course, basalt is lava.
Yes.
Yep.
And okay, these rays will go away eventually. Just the
Interesting.
They'll erode, and other impacts will deteriorate, and of course, then at the early stages of the moon's life, there was lava that would come flowing out. Most of that stopped around 2.5 billion years ago, but there was some volcanic activity even as late as 1 billion years ago.
Okay.
Okay, the next image is a 3-image cluster, and at the top is Theophilus, and then in the middle is Chrysalis, then down at the bottom is Caterina, and this shows the effects that one impact has on other impacts. Well, obviously, you can see Caterina at the bottom there is quite heavily cratered and
Looks somewhat eroded even. Yeah, it's been there a while.
It's taken a beating. Then the Chrysalis in the middle there, Theophilus hit it and took out a chunk of it.
Yeah, you can see that it's much sharper, more distinct.
More sharper, distinct, and that. Okay, the next image. Okay, this is Atlas and Hercules. Atlas is on the right, Hercules on the left. Now, Atlas is the lunar object.
Okay.
But when you look at, these are approximately the same size, they're very close together, so you look at the pairs. And they were both affected by volcanism. But they are two completely different floors. At Atlas on the right, you can see it's fractured. In here, the lava was underneath and pushed the bottom up, and then as it cooled, it fractured. You can kind of see I call it a chicken foot.
Oh yeah, I see it there.
Whereas Hercules, it was strictly the lava came in and filled the floor, and you have the dark halo crater in the middle there.
Yeah, you can see how smooth that one is versus the other one.
Yeah. Okay, now the next image is the Apennines Mountains. That's a wall. It's actually a basin wall, a segment of it, 600 meters of it. And it goes around, and if you could pan out and you'd look at it, you can see there's some indications of the whole circle of the wall that went around the basin. Okay.
So that was the mountain range where lava flowed up to sort of
filled it in and got rid of it, yes. Okay, and now the next image, this is one of my favorites, Messier and Messier A. They're the two in the bottom right-hand corner, Messier to the right, Messier A to the left, and you can see two nice rays.
Yes, you can.
That go out of it. And I've seen it before the sun gets up too high, and you don't see the rays. But this kind of perplexed people for a long time, because you notice the shapes of the craters, they're not the round shapes.
No, they aren't.
They are. And they couldn't figure out what happened here. And they couldn't figure out how we could get two distinct rays like that. Well, there was a NASA engineer, Don Galt, I believe was his name, was doing research with high-velocity particles, high-velocity, hypervelocity.
Okay.
And so found out that the craters, if the impact is over 45-degree angle, it's circular. But once you start getting under 45, it can change. And with these, Messier and Messier A, they figure their angles are less than 5 degrees.
Came in very low.
Came in very low.
Wow.
And they figure it would hit Messier hit first, and actually the top of the projectile broke and tumbled in and formed Messier A. And that's what caused the two distinct rays.
Okay.
And the thing is, you can see from Messier, there's going out to the right and to the left from the crater are fainter rays. These are called butterfly rays.
Oh, okay.
So that's what, and now, of course, now I've got to redo my notes because Messier A is no longer Messier A. It is now Pickering.
Oh, okay.
They went through and renamed a lot of them. Okay, next. Okay.
The base of this crater looks similar to the one we saw earlier with those.
Oh yeah,
the cracks and fissures.
Yeah, there's the Hesiodorus, which is the craters to the left, has a very doubled wall craters. It's a smaller crater, and it's got, the two outer walls and, a central peak. And Charles Wood did quite a study on this, and he found some 51 of these type craters.
Now now that you brought it to mind, well, this is interesting.
Yeah, this is called the Serpentine Ridge Formation. A lot of craters.
Ridge was formed by geologic features, I assume,
yes.
Early in the moon's history?
Early in the moon's history, probably edge of some lava flows.
Okay. They seem to have, filled in quite nicely.
Yes.
And this shot here, Gary?
Okay, sometimes I have to remember which shots these are. Okay. I'm going to pass, and we'll go to the next one just to see what the next one is. Okay, this is Arago, and that's the crater up in the upper right. And you'll notice it just above it to the north is a small dome, and to the left is another small dome. That's Alpha and Beta. And those are lava domes that were underground, and they just pushed up these domes. They're they're only maybe 20, 30 meters high.
Okay.
So you need lives to see them.
All right. This has been fascinating. We'll have some information on our club website where people can check into this information for themselves. I do want to thank you for taking time out of your schedule to come in and give this talk. We haven't had really many talks that I can think of on the moon on our program over the last 7-8 years now. So I'm glad we could have you come in today to do that.
My pleasure.
Again, folks, you can visit our club website to gather more information. And coming up next is Stephen Whitty with What's Up in Our Night Sky for January. Thanks for watching.
Thanks, Don. What's up in the night sky for January 2017? The new year, the sun rises at about 8 a.m. and at the end of the month, 7:47 a.m. So the days are getting longer, and the sun rises from 5:12 p.m. to 5:46 p.m. The first of the month, the first quarter, is on the 5th of the month, and we have the full moon on the 12th, and on the 19th we have the third quarter, and the new moon, which we won't see, is on the 27th. If we look at the solar system from the top, this is an Ori. You can see in the inner planets in the square up on the left, and the Earth is at the 11 o'clock angle. If you look at the objects sort of down and to the left, you see Mercury, Jupiter, and Saturn, and Pluto. And to the right, you see Venus, Mars, Uranus, and Neptune. And that splits the day and night visible planets. So we start with Pluto and Sagittarius and so on first. So let's start with Pluto. So this is on the 19th of January, which I'll get to in a second. Pluto is in Sagittarius. Now, we have superior conjunction in January on the 7th, so you're really not going to see Pluto. On this 19th, it's 3 degrees above the horizon at 7:45 a.m., and this is like looking through the grass. You're not going to see it, and especially something as faint as Pluto. Pluto rises at 6:29 a.m., but of course earlier, if you look at it earlier, it'll be even lower, so it'll be that much harder. Mercury is also in Sagittarius and has max western elongation on the 19th, which is this image. At 7:45, it's 10 degrees above the horizon. That isn't very high. That's going to be challenging. And if you're looking at Mercury, the sun rises pretty fast, so you don't want to be looking at the sun with a telescope. Mercury rises between 7:17 a.m. and 6:44 a.m., so it's actually better at the end of the month. Saturn is in Ophiuchus and rises between 6:35 and 4:51 over the course of the month. Jupiter is in Virgo and rises between 1:34 a.m. and 11:41 p.m. On the 19th, the moon is 3¼ degrees from Jupiter, so you might be able to see both in binoculars in the same view. So in the evening, and this is on the 12th of January at 8 p.m., Venus is in Aquarius, and then through the month it moves to Pisces, with max eastern elongation right here on the 12th of January. So that's as far up as it should go from the sun. Venus and Neptune are shown with the same dot here, and that's because they are 24 arc minutes apart. That is less distance than the width of the full moon. So they're very close, but Neptune is magnitude 7.9. It's very, very dim. You'll need at least binoculars to see that. And right next to it is Mercury, which is minus 4.3. It's very, very bright. Neptune sets between 10 p.m. and 8 p.m. over the month. Mars is in Aquarius, then Pisces, and it sets from 8:02 to 8, so it doesn't change much. And Uranus is in Pisces and sets between 1:32 a.m. to 11:32 p.m. On the night of the 3rd to the 4th, there's a meteor shower that has its peak, the quadrantids. Now, meteor showers are named for their radiant, and there is no quadrans constellation anymore. The radiant is in Bootes. The moon sets at 9 p.m. on the 3rd, so after 9 p.m., and actually after midnight, and in the northern hemisphere only, sorry, southern hemisphere people, because the radiant is so far north, really you only see meteors in the northern hemisphere. After midnight is best. I shouldn't have to say this, but dress incredibly warmly. And we may have a decent comet. This is C 2016 U1 Neowise. It is expected by the 14th to be at its brightest and be around 7th magnitude, which is not quite naked eye, but certainly binoculars. And so in this image, the comet moves through the sky from the top going down and to the left. And that is what's up in the night sky for January 2017. The show is Astronomy for Everyone, where we promise you the moon and we deliver.